So in this case, we are introducing the inclinations to one of the planes. Till now, the axis was not inclined, and the axis was either perpendicular or parallel to all the three planes. Now, in this case, what we introduce is we introduce the first inclination. So one inclination to either HP or VP. So when an inclination is given, the condition is you have to draw, when the axis is inclined to one of the planes, then you have to draw two different sets. In the first set, keeping the axis perpendicular to one of the planes, and in the second set, keeping the axis inclined to that plane. So let's see the exercise, the question for the exercise. Note it down. A right regular pentagonal prism, side of base 30 millimeter and height of axis as 75 millimeter, rests on HP on one of its base corners such that its long edge containing the corner is inclined to the HP at 60 degree. Draw its projections. The question is, I repeat, a right regular pentagonal prism, side of base 30 millimeter and height of axis as 75 millimeter, rests on the HP on one of its base corners such that its long edge containing the corner is inclined to the HP at 60 degree. Draw its projections. So in this case, a pentagonal prism is given. The sides of base, the side of the base is 30 millimeter and the height of the axis is 75 millimeter. And the condition that is it rests on HP is one of its base corners is resting on HP. One of its base corners is resting on HP such that its long edge, there will be only one long edge for the base corner, and that long edge is not a part of the base of the pentagonal part. It is perpendicular to that pentagonal shape. So that is the long edge will be always parallel to the axis in the case of a prism. In the case of a prism, the long edge will be always parallel to the axis. So any angle that is given to that particular long edge will be applicable to the axis also. So if that means its long edge containing the corner is inclined to the HP at 60 degree. So that means the axis is inclined at 60 degree to HP. So the questions will be like this. That is the long edge containing that particular corner. The corner on which it is resting on HP is inclined, and the long edge through this particular corner is inclined at 60 degree to HP. Draw its projections. This is the question. So note it down. Now let's visualize it, how it is. It will be like if you watch through. So this is the pentagonal prism. The pentagonal prism is this one. So in the simple position, actually we call it as a simple position when the axis is perpendicular to one of the planes. We call it as simple position. So in the simple position, it is resting on HP with its base on HP. Why it's base on HP? Because it has to rest on one of its corners. When we are rotating it, with respect to keeping the angle, the inclination with the VP constant, keeping the inclination of the axis with the VP constant, when we are rotating with respect to the HP, if it has to remain in the one of the corners has to remain in HP. So then it has to be like this. So let's see the second view also. So the second view will be like this. The second figure, when it is rotated with respect to the HP, when the edge on which it is, I mean the corner on which it is resting will be this corner, and the longer edge containing this particular corner is this edge, and this particular edge is making an angle of 60 degree with the HP. 60 degree with the HP. So if you see the front view in both the cases, see the front view will be the same. The only difference is, see the colors. This blue color is here. Here also that particular blue color is here. This is gray, and here also it is gray. The difference in shading is because of the small inclination that is given to that particular prism. So this is the corner on which it has to rest. This is this edge, this corner. This corner is the corner on which it has to rest. When we want to rotate it with respect to HP, the front view should not change. The front view should be the same, so that only the top view will change. The shape of the top view, the shape of the front view will be the same, but the shape of the top view will change. So now let's see the top view. See the top view. The top view in the initial case, it is only a pentagon. A pentagon with its base, one of its base perpendicular to XY. This is important in the simple position. This particular part is important. One of its base edges should be perpendicular to VP. Why is it so? Because when we are rotating it, it has to rest on this corner, the opposite corner. It has to rest on the opposite corner. So in order to make it rest on its opposite corner, we have to place it on one of the end point. It has one of the end points in the initial top view. Otherwise, if you rotate it, it won't be standing on that particular corner. So this particular point is important. When it is to be rest on one of its end points on HP, or I mean one of the corners on HP, it has to, one of the base edges should be perpendicular to HP, and it will be then standing on, once it is rotated, it will be standing on the corners which is opposite to this particular edge. So this should be the simple position, the initial position of this one. In order to draw it, we have to start from this edge, this perpendicular edge, or this vertical edge. From this vertical edge you have to start, because we doesn't know what are the inclinations of all the other four edges. So that we can find out, but obviously we doesn't want to find it out and then use it and start it from here. Actually, we know that this one is perpendicular to XY, so we will start from here. So this is the front top view, and in the second top view, it will be, the shape will be something like this. And when you draw it, it will be like this. See, all these edges are visible except three edges. These three edges. See, this edge, and this edge. These three edges will be invisible edges, since it is coming below. See, those are not visible because it is coming below the actual shape, the actual object. It is at the bottom of the actual object. So that is why it is not visible. In the front view, if you see the front view, see. This is the corner from which all the three invisible edges starts. This is the corner, this bottommost point. This bottommost point is from where all the three invisible edges are starting. See, in the top view, if you watch the top view, see, there will be three invisible edges starting from a single corner. So from the bottommost corner, whichever is the edges starting from the bottommost corner, those will not be visible in the top view. So that you can identify from the front view, which is the bottommost point and bottommost corner actually. So which is the top view in that bottommost corner, that also you can identify. And if all the edges starting from the bottommost corner will not be visible. Now, so first we start from here, this pentagon we start, then the corresponding front view we draw. Then what you draw is this front view. The first front view is then rotated, making an angle of 60 degrees with the XY line, that is in the second view. Then that view is projected to the top. So let's see it in, let's watch it in the PowerPoint slideshow. So this is our XY line. So the pentagon is drawn first with one of its base edges making 90 degrees with XY line, or it is perpendicular to the XY line. So this is the 30 mm length. A1, B1, C1, D1, etc. is marked. In the initial figure, we marked it as A1, B1, C1, D1, E1, etc. because finally, the final figure will contain the names A, B, C, D, E. So that initially we are not giving it as A, B, C, D, E. Even if we give A, B, C, D, E itself initially, it doesn't matter. So then the second set of endpoints, that is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 will be on one end of the prism, and the A, B, C, D, E will be the other end of the prism. Now the axis is obtained as in the previous case. No need to draw all these lines, only two lines is necessary. No need to draw all these lines, only 2 lines is necessary, because we need to find out only the axis. In this case, the apex is not needed. It is not the apex in this case, it is a pentagonal prism, so only the axis is needed. So from the axis, we draw the chain line, and the chain line should be of length 75 mm above the XY line. Above the XY line, it should be having a length of 75 mm. Then all the edges, 1, 1 as well as A1 is projected, and the A1 dash is marked at the top, and 1 dash is marked at the bottom. 1 dash is the point which is coinciding with the XY. So this point is 1 dash. It is slightly marked above, but this is the point. Then 5 and E. So in this case, when you project B1 and 2-1 as well as E1 and 5-1, it will be in the same vertical line, because of the symmetry of this pentagonal shape. B1, 2-1 as well as E1, 5-1 will be in the same vertical line. If you draw from here or here, both will be the same. So it is 2-1 dash as well as B1 dash will be here, and E1 dash as well as 5-1 dash will also be there. And when you drop the C and 3 as well as D and 4, it will be the same case. Both will be, all the 4 points will be in the same vertical line. So here it is C1 dash, then 3-1 dash. In the same line, D1 dash as well as 4-1 dash can be marked. Here in the front view, in the second case, E1 dash will be coinciding with the B1 dash, and 5-1 dash will be coinciding with the 2-1 dash. Then this is the shape, the front view. Only 2 rectangles will be there in the front view. Only 2 rectangles with the 5 points on the top and 5 points at the bottom. So this will be the front view in the case. Now what you have to do is you have to mark 1 dash. So we consider 1 dash to be the point on which the pyramid will be resting. The prism will be resting on the point 1 dash. So we first mark 1 dash. This point 1 dash is marked. Then from 1 dash, we draw a line which is of length 75, equal to 75. That is this. We are actually reproducing this figure, this front view, with an inclination 60 degree with the XY line. So what we do is we first draw an line of length 75 millimeter length, which makes an angle of 60 degree with the XY line. This angle is 60 degree. So then we complete the rectangle here. So this point is A dash, this point is A dash, B dash, C dash, then B dash, E dash. So that points are marked here and here 1 dash, 2 dash, 3 dash and 4 dash, then 5 dash. So this figure is repeated here or exactly replicated here. So you can use your compass as well as your divider or your scale, pencil, etc. to reproduce this figure. The same shape. This is a rectangle. This should also be a rectangle of the same shape. Now, once this one is completed, the next step is you want to find out the front in top view. Now front view is completed, very simple. But in the top view, you have to find out all the points 1, 2, 3, 4, 5, A, B, C, D, and E. All these 10 points you have to find out in the top view. So in order to get point 1 in the top view, what you have to do is you have to drop a perpendicular, I mean a projector from 1 dash, this line. This is a projector from 1 dash, and then a horizontal line from 1, 1. A horizontal line from 1, 1. So the point of intersection of this point, these two lines, this line from 1 dash as well as the line from 1, 1 will give you the point 1. So this is the point 1. From 1, 1, from 1 dash we are drawing a perpendicular line or a projector, and from the 1, 1 point we draw a horizontal line or a locus, and the point of intersection of the projector and the locus will give you the point 1. Now point A, from A dash we are dropping it, and here also A1 as well as 1, 1 is the same. So in this same straight line we will get A. This is point A. Now point 2 and B, then C, D, and E. A, B, C, D, and E is obtained. Likewise, 1 is obtained, 2, 3, and 4, and 5. Now what you have to do is we have to join all these points. You know that A is joined with B and E. E is joined with D. D is joined with C. C is joined with B. So that you have to join. Now, in order to get the axis also you can mark here. Now, A is joined with B, B is joined with C, C is joined with D, D is joined with E. And when we join 1 with 2, 2 with 3, 3 with 4, 4 with 5, then 5 with again 1. You have to keep in mind that 1 is the lowest point, and so all lines starting from 1 will be invisible lines. So those lines should be drawn as dotted lines. So all the lines starting from 1 should be drawn as dotted lines. So 1, 2 and 1, 5 will be dotted lines, and all other lines will be continuous lines. So now finally what you have to do is you have to join 2 with the B, 3 with the C, 4 with the D, 5 with the E, and 1 with the A. 1 with the A will be dotted line. It will be something like this. See, this will be your final figure. Okay. So I'll explain once more. Shading, you don't have to shade it. It is for easy representation. First we draw the pentagon with one of its edges perpendicular. Then we mark the points in the front view, the coordinates. We mark all the 10 coordinates. Then we find out the axis. Then in the front view we draw the axis. Then in the front view we draw the we mark all those points, all the 10 points, and then we complete the front view. Then the front view is rotated as the second front view. Then all the points in the front view, all the coordinates in the pentagonal prism is found out in the top view also. First we find out 1, then A, then B, then C, D, E. Now to get the point A, what you have to do is you have to start from A dash. You start from A dash, you draw a projector from A dash, then a locus from A1 also. So the point of intersection of the projector and the locus will give you the point A. Likewise, you have to find out B, the projector from B dash, the locus of B1. C, locus projector from C dash, the locus of C1. So likewise, you can find out A, B, C, D, and E, and 1, 2, 3, 4, and 5. Then finally, you have to find out the endpoints of the axis also. Then join all the lines. So this is the final drawing.
So the second figure, that is at an angle 60 degree, that one is of the same dimension as that of the other one, no?
Yeah, sure. This rectangle is the same as this rectangle. Both the rectangles will be the same.
Okay, sir.
Actually, what we are doing is we are reproducing this particular figure, this first front view, with an inclination. We are reproducing the same thing.
So distance between XY line to below prism, other defined
നിങ്ങൾക്ക് കൺവീനിയന്റ് ആയിട്ടുള്ള ഏത് ഡിസ്റ്റൻസ് വേണമെങ്കിലും എടുക്കാം. ടോപ്പ് വ്യൂയിലേക്കുള്ള ഡിസ്റ്റൻസ് അല്ലേ ഉദ്ദേശിച്ചത്? അത് ഏത് ഡിസ്റ്റൻസ് വേണമെങ്കിലും കൺവീനിയന്റ് ആയിട്ടുള്ള ഏത് ഡിസ്റ്റൻസ് വേണമെങ്കിലും എടുക്കാം.